Solving geometry questions can be confusing and tricky, which means knowing the theorem might not be enough to solve any geometry question. Ability to visualize and look out for the theorem that we've known is the only key to solving geometry question. You're welcome to Dynamic Educational Hub channel. This is a channel where we dissect various topics in maths, physics, and chemistry. And in this video, we are going to learn a theorem. And before we learn that theorem, we are going to solve an example, which is a continuation of the previous video. If you haven't watched my previous video in this playlist, kindly check out my channel, watch the video. And even if you haven't subscribed, kindly subscribe to my channel and click on the notification icon to get notified when I release new video. Without further ado, let's start. This is the first question we are going to solve. From the diagram, ABT is a circle with center O, PQ is a tangent to the circle at T, and CT bisects BTQ. Find I, angle BTQ, II, angle CTQ, and III, angle BCT. To solve that, let's have our question. Now we can see that from the question and from the diagram, we are given the value of angle ATP, which is 60 degrees, and angle BAT, which is 44 degrees. Observing our diagram, we can see that this angle over here, which is 60 degrees, is the same thing with this angle over here. And why is it the same thing? Using alternate segments theorem, which is the theorem from the last video. You can clearly see that this angle and this angle, they are the same because this angle is in alternate segment. This angle is formed by this chord at the point of contact with the tangent, and the other chords form this angle at this point. I've explained the theorem, so that is why the two angles will be the same thing. So which implies that angle ATP, this 60 degree, will be equals to angle ABT, which is this, and everything is 60 degree. Alternate segment theorem is being applied. And looking at this triangle as well, we have a triangle. Let's see how to use that triangle to find the next angle. From triangle ABT, we have drawn that triangle. Angle BAT plus angle ABT plus angle ATB is equals to 180. We are applying some of the interior angles of a triangle. So which means that this angle, which is angle BAT, plus this angle, which is angle ABT, plus this angle, which is angle ATB, is equals to 180 degree. So we can make ATB subject of the formula since we know the value of angle BAT and then we know the value of angle ABT. So we can make angle ATB subject of this. And if you do that, we are going to transfer BAT and ABT to the other side. Transferring it, their sign is going to change from plus to minus to negative. So we have 180 degree minus ABT minus BAT. Solving that, we are going to get 180 degree. You bring out your minus 1. So we are applying the knowledge of algebra now. When you bring out minus 1, so you can simply turn this sign here to plus. That is what I've done here. Or you can simply insert the value of angle ABT and angle BAT. You can do it either way. So 180 degree minus BT plus BAT. So when you insert the value, you get 180 degree minus 60 degree plus 44 degree. Doing that, you get 180 degree minus, what is 60 degree plus 44 degree? You get 104 degree. When you subtract 180, when you subtract 104 from 180, you get 76 degrees. So we have gotten the value of angle ATB. So the next one, we want to find the value of angle BTQ. And we know that angle BTQ will be the same thing as angle ATPY. This angle here, BTQ, and this one is in alternate segments to this one. I've explained it. So which means that BTQ will be the same thing as ATP. 44 degree alternate segment theorem is being applied. And we also know that from the diagram, mere looking at the diagram, we see that angle BTC is still the same thing as CTQ. Why? You see, we have double sign here, double curve here, and double curve here. And according to the question, we are told that CT bisects this angle BTQ. So which means that this angle over here will be the same thing as this angle. So BTQ is the same thing as BTC. We have our BTC, this angle here, plus angle CTQ, CTQ, this angle, because CT bisects it into two equal angles. So since the two angles are the same, this angle is still the same thing as this angle. So we can say that BTQ is equal to CTQ plus CTQ. Since CTQ is still the same thing as BTC, you can also say that BTQ is equal to angle BTC plus angle BTC, since they are the same. So that is what we have here. CTQ plus CTQ, we have 2 CTQ. So BTQ is equals to 2 multiplied by angle CTQ. If you rewrite this, writing this first before your equal sign, you can get 2 multiplied by angle CTQ will give us angle BTQ. To find the value of CTQ, we divide both sides by 2. So we have BTQ divided by 2. What is BTQ? Which is 44 degrees divided by 2. That will give us 22. So we have gotten the value of angle CTQ. Now to solve the third question, so we know that angle ATC will be the same thing as angle BTC. This is BTC plus angle ATB. Now if you add the two angles together, we know that BTC is 22 degrees and ATB from the first question that we solved is 76 degrees. Adding the two together will give us 98, and that is the value of angle ATC, this angle over here. Now we have triangle ACT. This triangle ACT has shown BAT plus ATC plus BCT will give us 180, sum of the interior angles of a triangle. So this is BAT, angle BAT. When you add it with ATC over here, and when we add it with BCT, we are going to get 180 degrees. And to find the value of BCT, we can simply move BAT plus ATC to the other side. So we are finding the value of BCT here. So we can carry these two guys and take it to the other side, or we subtract these two guys from the two sides. So when we do that, we have this. Substituting their values into this equation, we know that BCT will give us 180 minus, what is BAT? 44 degrees plus, what is ATC? 98 degrees. So that will give us 180 minus 142. 44 plus 98, that's 142. And 180 degrees minus 142 degrees, we get 38 degree. You can see that questions like this are simple when you know your theorem and how to apply your theorem. To the ninth theorem, which says that two different tangents from the same point to a circle will have equal lengths. That is, the length of the two tangents from their origin to their point of contact with the circle are equal. Let me come again. Two different tangents from the same point to a circle will have equal lengths with the point of contact with a circle. And let's have our circle here. Let's have the center of the circle. Let's call that point O. Let's have an external point. Let's call that point A. Let's draw a tangent from that point to a circle, and the point of contact with that circle, let's have it and let's call it point B. So we have a tangent here. Let's call it the first tangent, tangent 1, the first tangent. Let's have another tangent drawn to that circle, and the point of contact with the circle, let's call it C. We have the second tangent. What this theorem is now telling us is that the length of these tangents to the point of contact, that is length AB, is not the entire length of this tangent. I'm not talking about here to here, but from here to B. That is what we have here, AB. And the length of AC from here to here, point of contact with the circle. So what it's telling us is AB will be equal to AC. So if this one is, if AB is 10 centimeter, AC will also be 10 centimeter. That is what this theorem is telling us. But before we proceed, I would like to expatiate more and show you how to apply this theorem to solve geometric question. From the center of the circle, if we draw a line to the point of contact B, we have a radius. There is one theorem which says that the angle between the radius and tangent at the point of contact with the circumference is a right angle. So we have a right angle here. Now if we draw the same another line from the center as shown to the point of contact, the angle between them will also be 90-degree right angle. We are going to have angle here as shown, angle between the two radius, the two radii. We are also going to have angle between the two tangents as shown. If you draw a straight line to connect the center of the circle to the point of origin of the two tangents, that line is going to bisect this angle as shown, and it's also going to bisect this angle as shown, and it's going to bisect them into two equal angles. So we are going to have, what I'm going to have, it means that this angle here will be the same thing as this angle here, and this angle here will be the same thing as this angle here. And you can be given a question where you have two tangents like this and you have 50-degree here. You can divide that 50-degree into two, and if peradventure we have a line from here to the center, and the angle between that line and the first tangent, you can divide into two, which means it will be 25 and this one will be 25. That's another way of applying this theorem. So let me show you another thing that you can do as well with this theorem. If you carefully observe this shape very well, we have a quadrilateral, which is a kite, quadrilateral ABOC. And if you look at it, you can see that it is made up of two right angle triangles, which is ABO and AOC. If you also cut it along this plane, we can say it consists of two isosceles triangle ABC and BOC. From the diagram, ABCD is a circle with two tangents from T. PQ is a tangent to the circle at T. Find the marked angles. Again, from the diagram, ABC is a tangent with 2 tangents from T. PQ is a tangent to the circle at T. Find the max angle. Let's see how to solve this. Looking at our diagram, we can see that we have a quadrilateral, cyclic quadrilateral as shown, and we can apply the theorem of cyclic quadrilateral. Opposite angles of cyclic quadrilateral, when you add them together, they are supplementary, and that is when you add them you get 180. So which makes it that 100 degree plus this W or W degree will give us 180 degree. So that is what we have here, opposite angle of a cyclic quadrilateral. So to find W, you are going to get 180 degree minus 100 degree, and that is 80 degree. To find the value of X here, we have this quadrilateral as well. And why do we want to use this quadrilateral to find the value of X? Let me show you. We know that the angle between a radius, OA is a radius and OC is also a radius. The angle between this and this is right angle. This and this is right angle. So obviously we have known 3 angles. We know this, and we know this. So we can use it to find the third interior angles. And this angle is right angle 90. This angle is also 90. So let's apply that. So it means that 70 degree plus 90, this angle plus another 90 plus X will give us 360 degree. Applying that again, 70 plus 90 plus 90, that will give us 250. 250 plus X degree is equals to 360 that we have here. To find the value of X, what are you going to do next? X will be 360 degree minus 250, and that will give us 110 degree. So the value of our X will be 110 degree. The next one is we want to find the value of Y, and to find the value of Y we can use this quadrilateral that is drawn. Why do we want to use that quadrilateral to find the value of Y? Let me show you. We know the value of W here. We've known the value of X here, so we can find the value of these interior angles, this reflex angle that is inside. The quadrilateral that is shown is a convex quadrilateral, so we can find this angle here. And when we know that angle and when we know this angle, we can see that OC is radius and OA is radius. And from the diagram, BC is still the same thing as AB. So that definitely this angle will be the same thing as this angle. Let me show you. So we want to find this value first, this angle. To find that, let's call that one X prime. X prime will be 360 degree minus 110 degree. And why is it 360 minus 110 degree? It is angle meeting at a point, angle at a point, and that is 250 degree when you subtract 360 minus 110. This angle shown here will be the same thing as this angle shown here. I've explained it. OC is a radius, OA is also a radius, they are the same thing, and from the diagram AB is also the same thing as BC. So which means that whatever value we have here will still be the same thing as what we have here. Applying that, so it means that X prime plus W, this angle, plus 2Y. Why is it 2Y? This Y plus this Y, making 2Y, will give us 360 degrees, sum of the interior angles of a quadrilateral. Making 2Y here, and you want to transfer X plus W to the other side, we have minus I. You can choose to put the value of X prime and W here and solve your question. I just want to use another approach from algebra. We want to make Y sort of formula. That is what I'm doing here, John. Now 2Y will give us 360 minus X prime plus W. Making Y sort of formula, divide both sides by 2. We're going to have 360 minus X prime plus W divided by 2. Substituting the value of x prime and w, we have 360 minus 250 plus 80 degree over here, 250 for our x prime. When you do that, you are going to get 360 minus 330 over 2, 250 plus 80 degree, that will give us 330, and 360 minus 330 divided by 2. What is 360 minus 330? That is 30 degree. Divided by 2, that will give us 15 degree. Now to the last question, which is our z. We want to find the value of our z. To find the value of z, this is the angle that we want to find, which is z. We have three angles that is present here, and this is how to solve it. Looking at the diagram, this angle is right angle, which is angle between this radius OA and this tangent TA, and the other parts which make up the angle that we are looking for is also y, which makes it z is equals to 90 degree over here plus y, and that will give us 90 degree plus 15 degree, which happens to be 110 degree. We can see that visualization and application of the theorems that we know has enabled us to solve this question. We've come to the end of this video, and thank you for watching this video. And if you haven't subscribed to this channel, kindly subscribe to this channel. Click on the notification icon to get notified when I release a new video like this. You can also check my various playlists and watch those videos in order to learn. Thank you very much. See you in my next video. Bye for now.